Okay, so in this part 2 about vectors, you're going to do the exact opposite as what we just did, which is you're going to take coordinates and then you're going to describe it by a magnitude and a direction. And so it'll be a question like this: find the magnitude and direction of the vector 4, 9. So remember, this means 4, 9 with those arrow-like brackets means that there is a terminal point at 4, 9, and your vector starts at 0, 0. And so we want to find the magnitude and direction, which means we need two things. We need to know how long is the vector, because that's our magnitude. And then we need to know what this angle is right there. Well, both of those actually are very simple to do. The magnitude, if you're given the points, is simply going to be the square root of x squared plus y squared, because all you're doing is the Pythagorean theorem. And so you just do 4 squared plus 9 squared equals the magnitude squared. You take the square root. So in this case, it's going to be the square root of 97. Well, you can leave it exact if it asks you to give you an exact answer, or you can do rounded to the nearest hundredth, which would be 9.85. And so the magnitude of this vector is 9.85. And then the direction, well, you're given the y and the x. Well, notice how that is just going to be tangent, because 9, or the y, is the opposite, and 4, or the x, is just the adjacent. So you're going to say the tangent of theta equals 9 over 4, and so you just do the inverse tangent of 9/4. And so you type in the inverse tangent of 9/4 into your calculator, and you get 66.04. And this is north above the east direction. And so our vector is going to be 66.04 degrees. And we can use abbreviations if you want: north of east with magnitude 9.85. Okay. Then if you had one like this, which would be negative 4, 3. So we put that on our grid. Negative 4 is in the x direction, a positive 3 in the y. And so negative 4, 3 would put you through at this point. This one's easy because when we find the magnitude, it's just going to be a 3, 4, 5 right triangle. So the magnitude for this one is just going to be 5. And so then we need to find this angle. And again, it's the same idea. Now be careful here. You don't want to do the y over x in the sense that you're going to get negative 4/3. We're worried about this acute triangle, and so we need to use positive y's and x's. I mean 3/4. And so when we do the tangent of theta, we need to do the opposite, which is 3, and the adjacent, which is 4. And so we're going to do the inverse tangent of 3/4, not negative 3/4. And so the inverse tangent of 3/4 gives us 36.87 degrees. And so this angle right here is 36.87 degrees. So our vector is going to be 36.87 degrees north of, and this time we're going west. And so it's north of west with magnitude 5. Okay. Now there's two other things that we're going to have to do. The first one is to find the magnitude and direction of a vector with initial point 2, 5 and terminal point 7, -2. Okay. Well, to do this, there's going to be some procedures we can do, but let's just think about it for a second to start with. If we have 2, 5, that's going to be 2 over 5 up. So this point right here is 2, 5. And then 7, -2 is going to be about right here. And so our vector starts at 2, 5 and ends at 7, -2. And so that is what our vector looks like. And what we need to do is we need to move that vector so that we move the 2, 5 to the origin. Remember, when we deal with vectors, we want to take that initial point and put it at the origin. So the first thing we do with our vector is we move it to the origin, and it looks like this. Well, what we need to do then is find out what did we do to this coordinate? Well, to get 2, 5 to the origin, we subtracted 2 to get 0, and then we subtracted 5 to get 0. So that's what we're going to do to this. We're going to subtract 2 from the x coordinate to get 5, and subtract 5 from the y coordinate to get -7. And so our vector, this vector, and by the way, if we gave them letters, if we called this AB, we do vectors using this. This is it looks like a ray, except that we only put one side of the arrow above it. That means vector, and that means starting at A and going to B, right? The going to is the key. The initial point is the letter that is above the non-half arrow part. The terminal point is the letter that is beneath the arrow part, or the half arrow part. So in this case, the vector is going to be 5, -7. Then we need to do the same thing we did up here. You find the magnitude. Remember, the magnitude is just the x squared plus the y squared, because you're doing the Pythagorean theorem, right? This is 5, this is 7. And so that's going to equal the square root of, 74. And the square root of 74 equals 8.6. 8.60. And then the magnitude is just going to be the tangent of the angle. Remember, and it always just turns out to be the absolute value of the y over x. So 7 tangent of the angle equals the y, which is 7, over the x, which is 5. And so we do the inverse tangent of 7 over 5. And that gets us 54.46. So theta equals 54.46 degrees. So our vector is a 54.46 degrees. It's south of east, right? This is east. We went below it, so south of east, with magnitude. But to do this, you had to do this. And the way that and turn it into 5, -7, and it always turns out to be, and this is very important, to find the coordinates between of a vector x, y, it's always going to be the terminal point. I would write this down, minus the initial point. If you're given the coordinates of a terminal point and an initial point, you subtract the initial point from the terminal. Make sure you do it in that direction. Draw a picture of it to make sure what your answer you came up with makes sense. But it's just terminal point minus the initial point to find those. Okay, the last thing that we're going to do is we're going to deal with adding vectors. And so the adding vectors, well, vectors are added by 2 vectors are added together by placing the initial point at the terminal point of the second vector, or vice versa. And so what that means, if I've got 2 vectors, and so let's say I've got the vectors that, we'll just do some generic ones, one that looks like this and one that looks like this. If I add them together, what I do is I take this one, I take this initial point, I move it up here. So this becomes the initial point of this vector right here. And then I have that vector start there instead of at 0, 0. And then the sum of the 2 vectors is the vector from 0, 0 that ends right there. And we call this the resultant vector. Now, it actually doesn't matter the order you did it. You could have also taken the initial point of this one, the longer one, and put it at the terminal point of the shorter one. And if you did that, what you end up with is the exact same resultant vector. It turns out to be the diagonal of this parallelogram created, where the vectors are the sides of the parallelogram. So it doesn't matter the actual order that you add the two the vectors together. The resultant vector is going to be the same either way, which is really nice. Now, the really great thing is, because that's geometrically, it's complicated, and trying to find out information about this resultant vector by using just geometry is really hard, but it's super duper easy using coordinates. And all you need to do is the sum, if A, and so we'll call vector A is x1 comma y1, and so the vector, the coordinates of the endpoint is x1 comma y1, and vector B is x2 comma y2, then all you need to do to find A plus B, the resultant, when you add those two together, is just add their coordinates together. So adding vectors together is really, really easy to do. All you need to do is find the is add the coordinates. So if I say, as an example, that the A is 5, -2, and B is 2, 7, and I say find the resultant vector A plus B, magnitude and direction. Well, I don't find the magnitude and direction of these two coordinates separate. What I do is I first add them together, and so I just add, and so A plus B, we add those together, and we get 7, 5. And now I need to find the magnitude and direction of 7, 5, and so I come over here, I do 7, 5, 7 over, 5 up, and I do the same thing I did before, which is I find the angle and I find the length. So the length, remember, is just the square root of x squared plus y squared. So square root of 74. And the angle, remember, we use tangent, and so we say the tangent of theta equals 5 over 7, y over x, opposite over adjacent, right? And so we do the inverse tangent of 5/7. That gets us 35.53 degrees, 54 degrees. And then the square root of 74 is just 8.6. And so the resultant vector, when these two vectors are added together, has a direction of 35.54 degrees north of east with magnitude 8.6.